Good morning. Thrilled to have you guys come and join us this morning. We knew we were kind of up against a triple threat here, with it being the last day of the conference. So you guys are probably a little fatigued. I believe there was some kind of celebration last night, and then we also got the first session in the morning. So hats off to you guys for getting up early and coming. And we will make it worth your while. We've got some real good stuff to share. So my name is Andrew Schneiderman. I work on the Skype engineering team. I've been at Microsoft about 15 years now, and at least half of that career has been working on this product. And I have a couple of folks from my team that will come up and do a session apiece, do a kind of a segment apiece. I have Jens Thure Rasmussen here, and he'll come up and he'll cover the work we've done in the call quality methodology, and Brandon Bernier, and he'll come up and cover the work we've done in key health indicators. So this is the part of the session where I tell you everything we're going to talk about, and then you have the option to go, that's not for me, and you can leave, take a nap, get some more coffee, or hopefully this is what you're here for. But this is a body of work that our team has probably been working on for a couple of years. And the KHIs and CQM really go together, and it was born out of working with customer deployments that had maybe gone astray, that had kind of gone in a bad direction. And our team gets called in sometimes in those cases. So we knew we have a rich set of tool sets in the product to do monitoring and alerting in health, but we felt there was a little more we needed to do here around making sure we understood the very small subset of things that you guys all need to keep the close eye on to make sure your deployment just sings. So I'm going to give a little bit of an overview, talk about the resources we have for you, kind of give you a little bit of a top 10 list. What are these key things and why do we select them? At that point, I'll hand over to Brandon, and Brandon's going to demo for you a new tool we have that will allow you to analyze the key health indicators, which are server-side perf counters, and talk about how to remediate those and what you do if you see those going red. And then after that, Jens is going to come up here and talk about what we've been up to with the call quality methodology. And we have a new release of the call quality methodology coming out. We also have a new server-side tool in Skype for Business Server called the Call Quality Dashboard. So a lot of the work we've been doing in CQM is to make sure the methodology, which is CQM, aligns with the tooling in CQD, and that the two approaches are consistent and you can use either one. So that's what we're going to cover. So on Sunday, before I came to the conference, I decided I'd kick off a little dev project, and I found a couple of cups, and it took me about 15 minutes was the dev life cycle of this thing, which is a good thing because I had a plane to catch. The duct tape, I had to find the duct tape because I punched too big a hole in one of the cups, so it took me a little longer. But I'd always want to do this, and my idea was I could get like a case of cups, and we get a bunch of string, and we could all get down in the audience, and we could imitate a link deployment, right? This could be a data center, that could be edge, and that could be a site. We tried this out. We did a little regression testing, and actually my kid, who's mainly into looking at Instagram, was actually really entertained by the fact that this actually worked. It was like 20 feet of string, and I went inside and I closed the door. And I'll tell you, the call quality was pretty poor. I couldn't really understand exactly what he was saying, but I could tell he was talking. But the expectations from the user perspective were low. So from my point of view, it was successful. And then when we went to ship, we had a little issue. The dog found this very entertaining too, so I did not bring these with me. But the idea is that this is obviously the simplest of simple systems, and what we find ourselves in is actually something very different. And it actually is a very complex system. And I had the misfortune of spending a little time in the hospital recently, and it occurred to me that diagnosing a human and running tests and looking at test results and trying different things is very similar to what we run into as admins for Link in a complex system. And we really have a very complicated system here. So you see in this diagram, and I got to apologize, I missed one Link icon. So if you find it, come up after and I'll give you a t-shirt. Yes, okay, that was an easy one. But of course, I didn't see it, so no T-shirt for me. Viz? Well, it's called the call quality methodology. So it's an interesting question. We actually thought about adding video even before Viz to CQM. But the key thing is audio has got to be nailed, right? I mean, that's the key to our service. Video, you have a little more tolerance for it. By the way, we have a bunch to cover, so I think what we're going to do is take questions after and do the mic thing. We'll try and make that work that way. So totally want to take all your questions, and we'll stick around after if we need to. But want to get through this stuff too. So what does this thing look like? So on the far right, we have potentially a site or a branch. It has a mediation server as a gateway. And we also have users. We can't forget about our users. And our users connect in different ways now. They have different endpoints, whether it's a phone or a PC. And they have different devices, whether it's a speakerphone or a USB headset or a Bluetooth. And now they can connect over wired and wireless. So we can't ignore that connection point. But then they potentially, depending on the type of call they're doing, they will traverse to the data center where they have an MCU. And if I had that string analogy, we'd all have cups with string, everybody traversing different ways to get to that MCU. So that becomes a central point. And then if there's somebody who doesn't have the luxury of having a cup, is calling in over PSTN, then they have yet another path where they're going through a gateway and they're going through a mediation server, and then they're hitting the MCU, or then they're hitting the person. I'm sorry, the conference. And then finally, we have an entire population of users, and in more and more customers that I work with, that's the biggest population that are outside the corporate network, that are off-net, and they're coming in through our edge servers. And we know that's, in some cases, the hardest, because how do you assert a quality SLA over an unmanaged network? So this is how we look at the problem. This is how we carve it apart into these 10 different areas and solve it. So the yellow circles that then overlay this diagram are queries that we can put into our quality of experience database, which we insert a record into every time we hang up the phone from a call. Every endpoint, with few exceptions, put a record into that database, including server-side components, the mediation for its leg of the call, the AVMCU for its leg of the call. So we can pull information out of this database, and you see with the yellow, we have coverage all the way down to that last mile where the user is, through the WAN, across to the data center, and then within the data center, between our servers ourselves, the MCUs, the mediation servers, we can look at those streams as well. The pink circles are the pre-call diagnostics tool that we have. So Edge doesn't terminate media, it relays it. So we don't have a lot of visibility into that one area. But pre-call diagnostics, which coincidentally we shipped today, an update for PCD, or yesterday, sorry, it's too early today. Yesterday, an update to PCD for Link Online. PCD didn't work for Link Online, now it does, which is really useful, because for Link Online, everybody's typically going through that internet access. So PCD will give visibility into the edge components of that. So a word about, so this clicker has to be clicked that way. A word about the customer impact of that. So I stole this slide from our friends at Accenture, who had a session earlier this week, and I encourage you guys to go back and listen to it if you didn't make it. It was a terrific session, but I thought I'd steal this just to show how this can be really useful for you and for your customers that you work with. So in this case, Accenture's made this really pretty diagram. At the top, it shows different types of calls, and it's important that we classify the calls to figure out how we can, what quality targets we want to hit. So the best call, the call that should be absolutely great almost all the time, is when you're wired, not wireless, and you're inside on your corporate network. Peer-to-peer should be the best, right? Because then I'm not even necessarily going to the data center. But a conference call should be good as well. So that's, I believe, that very bottom line in this diagram. And the other two show different combinations of wireless. It's harder to get to high quality with wireless because we know, wireless, and when you're roaming, particularly you have lossy networks, and it's hard to apply QoS. But you can see in this case, Accenture's managed to get that inside down to below 1%. And that's awesome. And that's really what we want to do, is we want to look individually at our own deployments, figure out what's a good target, and work your way towards it. And Accenture is doing all that with this just ridiculous number of sessions, a very, very large and broad deployment, so really hard to hit. And it takes discipline, and it takes work. A couple other examples. We did a bunch of work with a public safety organization, and we started with KHI. We always start with KHI, because you can't do anything. You certainly can't blame the network guys if your own house isn't in order. So the very first thing we look at is our servers. And in this particular case, they had SQL contention that was resulting in delays in RGS. Ultimately looked like their storage system wasn't performing enough. So they upgraded disks, and we fixed that one. But then as we looked through CQM, we found everything from devices that were very, very old that they'd actually got from us in the TAP program 3 years ago that they'd never replaced, to a bunch of workstations that were running XP, and we had really high glitch rates. And so they go, oh, we don't have any XP. Well, they did. They had about 1,000 of them with very important people, so we replaced those. And then we saw a bunch of subnets that have high loss. They said, oh, we've got quality of service on all those. Well, not really. So we went and remediated those. They had a bunch of Cisco gear that we had to update that was dropping packets that we fixed. They also had folks that were driving around in cars. I think they were sheriffs, and they were using Wi-Fi over Link, and so it looked terrible when you looked at the reports because they had really high loss, but they were fine with it. It was better than a walkie-talkie. So that's a good lesson too, right? You look at the data, but you also have to look at it from the user perspective. One last comment I'll make from a customer perspective is sometimes we see customers that aren't even, that you've got to get the fundamentals right? So for example, keeping your servers current and making sure you're up at current patch levels. We had one customer, we spent so much time trying to figure out what was wrong, and it turned out they were at the RTM level of patching. And it wasn't even our patches that were causing the problem. There was over 150 network improvements, NIC side, file share side, that they needed to apply from Windows perspective, and then the problems just went away. So what's our top 10 list? So we've done a bunch of work in this historically, and one of the things we did is we made this a game, and we called it 3 Roads to Improving Your Voice Experience. And it was kind of modeled on Candyland, but they wouldn't let me use Candyland. There's some kind of a copyright infringement thing. But you actually can download this thing, and we've made playing cards. It's meant for the network admin and the link admin, and who am I missing? The IT admin, the network admin. Oh yeah, the IT guy, the network guy, and the telephone guy to get together in a room and get some pizza and beer and walk through this thing. But basically, it splits it into 3 different things in 10 areas, and I'll go through each of those. There's an 11th, and Jens is going to talk about the 11th, but it's reliability. So we've added a concept of dial tone to the CQM scorecard, because if you drop a call midway through or you fail to establish a call, those aren't things we pick up here. So it's important to look at those as well. So let me go through these top 10 real quick. So, and they're kind of coded according to that diagram. So the first thing we look at is from a server point of view. Let's look at your data center. Let's make sure foundationally you're in good shape. So that's where Brandon has done just a tremendous amount of work. And we shipped stuff even this week, new documentation, a new tool, and it's updated for Skype for Business. And basically, when we started looking at this, the product has around 8,000 performance counters. And what happens is as we develop it, devs will add their own set of counters, and it became really difficult to understand which of those 8,000 are actually important or interesting. So I think we have around 80 now. I think we even dropped a few in going to Skype for Business Server and added a couple for VIS, to your point, for the new roles. But basically, we went back to the component teams that write these to make sure we had the right ones and we had the right thresholds. So it's interesting to know what to measure, but it's useless if you don't know what you're measuring against. Some of these are cumulative counters, some of these you got to look at peaks. So there's a lot of nuances in how you measure them and what you look at. So that whole KHI bucket is a set of counters that you instrument on your servers and collect them and analyze them against a defined set of thresholds. And you can see right away, like in the customer example I gave before, if Sprock latency, for example, is really high, and then you can look at your disks and see if that's where your problem is. So that's the first thing we do. Next thing we do is we look at audio streams between your conferencing servers and your mediation servers. And because these are managed within your data center, these should be really good. And the same for mediation to gateway. Now, in some cases, you may have distributed your mediation servers out to your sites where your gateways are. So maybe that's a little more suspect. You want to look at those a little more closely. But for both of those cases, we do a very simple measure. We just look at loss. And whereas the classified poor call rating we use for generally a poor call, we look at loss of 10%. For these two stream types, we look at 1%. And this is the way we'll do it in the call quality dashboard as well. So that enables those particular stream types to pop to the top. So you can see if you have a problem within your managed data center. And I bolded, as we go through these slides, the one areas that we've changed. We used to do 1% and 5% max, and now we just do 1%. The last leg is a little bit tricky. It's the far side of the gateway. And you might have different brands of gateways. You might have SBCs. You might have SIP trunks. And so you've got to work with the manufacturer of that gateway to figure out how you look at that far end of that gateway leg. Some of the gateway vendors will actually drop a record into QoE, so you can use some of the same approaches we do here. Others will have their own monitoring tools. But a lot of times we see that the problem is actually on the carrier side or on the far side of that gateway. So you want to make sure you have visibility to that leg. Okay, so that's the server side of it. This side of it becomes a little trickier to measure, but it's really important. So this is what we call the endpoints road, or the set of things you look at for endpoint. And so we're looking at everything from, on the far left of this slide, the device. And for device, we key off of a metric called average send listen MOS. MOS scores are a measure of the quality of a call in different dimensions. In this case, it reflects the quality of the device that you're actually using. And we use a value of 3.6. MOS scores are on a score of 1 to 5. And basically, and these are all suggested values, by the way. You want to run this stuff in your environment and see if these values and targets make sense to you. But in this case, we use 3.6. And if you have devices that are not, you have less than 80% of your devices giving you a MOS score of 3.6 or above, we give you ways to pull the actual devices out, see if they're very old, or they need a firmware upgrade, or maybe they've just broken, right? Devices do have a limited lifespan, and you can actually contact those users that are having those problems and maybe ship them a new one. So that's device. The next one is system. So in the example I gave before, this customer had a bunch of old XP workstations. So this is when the system itself is injecting glitch, which is a noticeable audio anomaly into the call, and we use a value of 150. And we've actually changed that. It used to be 1,000, which turned out it was way too high, really poor audio. And when we typically run this at a customer, we'll see this really long tail that everything's fine, and there's just a handful of devices that are glitching. So we tell you how to find those and how to remediate those. We have a target of less than 5% of those. Media path, we look at two things there. First thing is, we don't want internal calls to be relaying off the edge. The edge will do that. In the ICE-done turn negotiation, it'll find a path. And if firewalls are internal that are blocking a peer-to-peer call, it'll relay through the external interface of the edge. But as you can imagine, that is not the best path for your media. So we'll look at that and we'll tell you if that's happening. And if it is, you want to figure out if there's some firewall in between that's causing that. And the last is VPN. And we know audio calls over VPN are generally sucky. You're double encrypting. Typically, VPN concentrators aren't built to handle media, so we'll pull that out for you. And we have a low target of 1% there. By the way, one thing we won't surface in CQM is looking at external calls. We'll show you how many calls are external, but we don't have a target for it because we know you can't. What can you do about it? But you need to be aware of it so that there's the right level set with your users. If they're in a Starbucks, and they're on the Starbucks Wi-Fi, and they're external to the company, their call quality probably is not as good as if they're sitting in their desk. Finally, transport. UDP is optimal for media, right? TCP has a bunch of retransmit, a bunch of stuff that's really nice for a lot of communications. For media, it's useless. By the time you retransmit, it's too late. So we prefer UDP, and if you're doing a bunch of traffic over TCP, we'll call that out, and that's another thing you should fix. And the last thing I will call out here is last mile. So we used to have a 5% target for wired and a 10% target for wireless, because this is where you get the most problems, right? This is the edge of your network. But in our internal work, so we have an initiative internally at Microsoft that uses these same approaches to get our call quality better. we found that we can hit a 2.5 target for wired now and a 5% call for wireless. So consequently, we've lowered those targets. Again, you pick the targets you want. Wireless requires a very intentional investment to make quality over wireless good. So you have to think about how you're doing that. So I think that's it for this. I'm going to pass it over to Brandon, and Brandon's going to dive into the key health indicators.
Thanks, Andrew. Quick show of hands. How many people have heard of the key health indicators? Oh, wow. Excellent. All right. Okay. All right. So the key health indicators, as Andrew's gone through and called out, it's really a refined list of performance counters that we know, if they go beyond threshold, will cause end-user impact within your Link or Skype for Business environment. So really what we wanted to do with the key health indicators was, we have a lot of experience. The guys, the teams that are running our service, that are running our internal deployment, most of these people have been with us since LCS 2003 and 5. So there's a ton of tribal knowledge that we had with inside of Microsoft. And when we would go through and encounter a new issue that would give us the opportunity to go through and get additional perf counters, it was really hard to go through and get this information in the first place. And we wanted to come up with a way so that you guys don't have to go through and experience this yourself. So our original goal was to go through and put together this list and some thresholds. So that's where we were 2 years ago when we released this for Link Server 2010. So for Link Server 2010 and 2013, this shipped with the networking guide. And what we tried to do is break it out by roles and components. And from what we saw was, it wasn't enough information. We thought that by providing the thresholds and the counters, our job's done. We've shared the information. But what we just found out was, that's really the beginning. So a lot of the questions that we're getting now are, hey, this is great. It's kind of hard to collect the data. It's kind of hard to analyze the data. There's not a lot of perfmon tools to go through and crunch this and get it in this Excel format that we originally shipped. And then, once you've done the analysis, what do you do? What do you need to do to go through and remediate? So what I'm really glad to announce here today is that in the last week, we've taken your feedback, we've worked on it for the last 6 or 7 months, and we have a new list of KHIs that for Skype for Business 2015, we added Viz, we found some KHIs that for 2013 that we thought would be more useful and weren't. We took those out of the list. We also updated our scripts. Our deployment scripts originally did not have the ability to deploy remotely. So you'd have to run a script on every server to create this data collector, and it was kind of painful. Another piece of feedback was that the scripts weren't signed, and that in some environments they have security mandates that do not allow unsigned scripts. So we've gone through, we've remediated that, and what I'm most excited about is that we've combined our original spreadsheet, which originally consisted of, here's the definitions and here's an example of how you can put counters into the spreadsheet, but we've turned it into a definitions workbook and an analysis workbook. So when you run our scripts to collect the data, the output is CSV files. And since the output is CSV files, we have this macro-enabled workbook that'll go through, crunch the data, and give you this analysis for which you can take action on. All right. All right. And then we've also spent a lot of time working through the guide. We went through all our source code to go through and figure out what makes all these counters increment so that we could produce a guide to give you actionable next steps if you need to go through and remediate. So the operational workflow, we kind of touched on it a little bit, is to collect this KHI data. We give some sample scripts, which is covered in section 2.1 of the guide, which I'll go over in a little bit. And then pumping this into the Excel spreadsheet. And then we have the option to go through and, if needed, remediate. And then once you remediate, as there's churn within your environment. For instance, you've applied a new CU, the networking team's replaced a bunch of gear. Anything that would be considered a significant change to your infrastructure, go through and then rerun the KHIs to make sure that you're within tolerance. All right, so we're going to jump right into a demo. Okay, so here we are. We're on my Hyper-V host machine. And what we're going to do is create data collectors on a Skype for Business server 2015 server and a Link server 2013 server. So to do that, oops. So now what we have to do, when we run the script, we have to give it a version because there's some capital letters and there's some spaces in the perf counters between 2013 and Skype for Business. So we had to go through and put in a version switch so that we're collecting the right data. So all we have to do is put that in. For Skype for Business Server 2013, in this script, we refer to it as Skype 4 and the letter B. All right, so you can see it was that easy to go through and create a data collector. So we'll do the same thing, but for Link Server 2013. All right, and it's created there as well. Let me show you what that actually does. So if we go over to my Skype for Business front-end server, you can see that I created a data collector. And I'll show you a trick. What's interesting about Perfmon and being able to script it with Logman, one of the things that we found, especially in pre-release, was that you can give Perfmon a list of as many counters as you want. They don't even have to exist on that server. So we don't have to go through and separate for on a front-end server. We can give it edge, we can give it mediation, and then when we go through and collect it, it actually only collects what's on the box. So it just disregards what's there, what isn't there. So if you ever have to do some custom Perfmon stuff, just keep that in mind. So we set the sample interval to 15 seconds. And the reason we do this is because if we're going to go through and try and assert the health and performance of a Skype for Business environment, we need to go through and make sure that we're getting this at a very quick interval. There are some performance counters, such as disk, where it's the average between samples that you're getting. So if you were to go through and have the sample interval set to a minute, unless there was something really, really bad going on in the environment, it has the potential to average out the next sample. So for that reason, when we first run KHIs, we strongly encourage that they're run every 15 seconds. And the file itself, all right, it starts with KHI, it has the server name, and then, let me show you where it is. I believe it puts it in, yeah, C perflogs admin. All right. So once you go through and we've created the data collector, it doesn't start them. It just creates them. We need to go through and make sure that the data collectors get started. Easy enough. So let's do this. All we have to do is type logman, KHI. I think it's -S for server. And we'll put in the FQDN. I forgot something. So logman, start, the name of the data collector, which is KHI. There we go. So you could go through and quickly, just for all the servers in your environment, take that same command, replace the FQDN with as many servers as you have, use that to start it, quickly edit it to go through and stop it, and then you can do something to copy the file as well to a central location. So that's it. In order to get this working in a remote environment, or to have it run against remote servers, there's one thing you need to look out for. Let me look here. In Windows Firewall, you need to make sure that you have the performance logs and alerts TCP in rule enabled. As long as you have that, then you can use logman from remote places to go through and do all the logman commands. It'll save you a whole ton of time. All right, so we're going to make the assertion that this has been running for a while. We've got some data. Now we need to do something with the data. So what we would normally do is come into this new workbook. You would hit Start and give it the location of where the CSV files are, what the folder is. And then it'll go through and process these files. So I will warn you, this has already been pre-processed. The reason I did that is because I have 12 files against some really busy front-end servers. And to go through and process it, it probably would have taken about 10 or 15 minutes. So that's why we went through and pre-processed that. So just something to be aware of. So what you can see here from what we're looking at is that there's these concentric circles. And what we can see from them is we've got ring 0, ring 1, and ring 2. Now this is huge because as we go through and look at KHIs, if we look at the outer layer, things that are in this second ring, what you'll notice is it's usually not that ring that's having a problem. It's usually something in ring 1, and more often something in ring 0 that's actually causing the problem. So therefore, when we go through and take on remediation efforts, we don't focus on the app layer level. We usually try to bring it in, and it's something much lower down that we need to go through and remediate. So I'll be talking more about that as we go on. Oh, also, if you're interested, I mentioned earlier about that there were some KHIs that we removed. We have a change log at the bottom here, so if that's important to you, you can go through and see what those are. We also went through on the KHI definitions, changed things around a little bit. You can see that there's now a product version in which we're showing what it applies to and what the rings are. And we break that out by system, front end, mediation server, SQL, and Viz, I believe. Cool. All right, so let's pretend I went through and clicked on the Start button. We processed the data. That will then give these 4 additional tabs, or worksheets, the charts, timeline, pivots, and tables. So what we're staring at here, if we look at the rings on the left, what it is it's showing us that it processed files from 12 servers and that it's reporting on the health of the ring per server. So it's showing that in ring 0, none of the servers fully passed the KHIs. It's also showing that for ring 1 and for ring 2, those did not pass either. On the right, we pivot a little bit differently. We don't pivot off of server. We take the number of counters that we have across all of the data, so in this case across all the perf counter instances from all 12 servers, and use that to go through and give a ring view from the total of perf counters. So we can see here that there's issues in ring 0, ring 1, and ring 2. But clearly, there's a lot of things going on within ring 0 that are problematic. So this is just to give you the at-a-glance view without having to dig real deep of, hey, if I have hotspots, where are they? Something that comes up a lot is when end users or help desk they come in and say, hey, we're having this problem. Something that's key to know, especially when analyzing the health of the server, is when do these problems occur? And knowing what the hour is going to be paramount to going through and understanding if what you're looking at in this data actually relates to the concerns that the customers are citing. So we have this new concept called burst rate, or burst counters. And what it is in the past, we used to have an average and a max. And what we found with it is that the definition, or the intended purpose of max, was not being used correctly. Because if it happened once, it would get flagged as red, and that it's bad. If it happens once, That's interesting, but that doesn't necessarily mean that there's a huge problem in the deployment. It just means that there's might be something small that you need to go look at. So what we've gone through and done is come up with this new metric called a burst rate per counter. So for every sample that is above a threshold for each perf counter, we increment the burst counter. And what this graph is showing you on this timeline is that the burst rates during the day are very high, that there's at least 45 perf counters across most of these servers that are beyond tolerance during the day. So we know that there's something serious going on here. We haven't got into what it is, but there's something big going on. Now, what's interesting here is you get to choose how you want to dice up the data. You can filter on it by ring, you can filter on it by server role, or if there's one server in particular that you want to look at, you can go through and look at that one server. Now, for me, this is my favorite. I think this is the most useful view. Again, you can go through and filter. We've got slicers for rings. You can look at suboptimal and optimal. I prefer just to look at the suboptimal pieces. You can filter by role and, again, with server names. Now, from looking at this, we can go through and see that we're filtered on all the rings at the moment. And there's a lot of stuff here that's beyond threshold. So if we were to go through and peek at it, if we wanted to look at the second layer, we can go through and see that there's some total counters in here. Like, for instance, this failed validate cert calls to the cert auth provider. Usually something that happens when external certs are used and the wrong trust is in place. So you can see here that the burst, from looking at the average, something seems kind of out of whack. From looking at the burst rate, it's 61,000. Well, how could that be? The reason that we see numbers that high are because when we break things down, this pivot is using the data from the timeline view. So what we do is we break things down by hour, and then we're taking the mean of the hour for the average and max, or min and max, and that's where these values are coming from. So because this is a total counter, we look at it a little bit differently. So the numbers are going to look a little off. So we take the average from the max to see what the delta is, and then that's what the burst rate is for that hour. Then we add all those together, and that's how we come up with those numbers. And you can see here, if there was an hour in particular where you wanted to go in and see where things were high, you can definitely do that by server. So totally cool. All right. Some things here that I think are super interesting. And again, from working with the product for over a decade, what has yielded the most results is particularly looking at these queue and sprock latencies, right? And the reason that this stuff is so important is because these are queues. In their queue, the more time that they spend in the queue, the less it's real time in terms of doing what the user expected that the client's doing. So the name of the game is to go through and drive down the numbers of those counters. Typically, it's done by doing things at the system level. But it's not just those queues. There's other queues. There's not only the request queue for instance, these queue latency. These are measuring the amount of time they're spent in a queue to a certain database, whether that's RTC, RTC Dyn, our backend. Those all have tremendous impact on each other. So those are key. But they're not the only queues, as I was alluding to. There's also networking queues. Things come into your server, it gets in-queued, de-queued, processed in another queue, has to go back out. So there's a lot of queuing going on. So we need to make sure that not only from the database layer, from what we're seeing in these queue and sprock latency, but also from the networking layer that we drive down these numbers. If you drive down these numbers, odds are you probably don't have a problem with your servers. So we can see here from looking at this, let's look at the RegDB, that the max here, the max was in the 500s, but for FE01, it jumps up to 4,000, and it happened a couple times. 4,000. So that's 4,000 milliseconds, which is 4 seconds. So a request spending 4 seconds in a queue, that's way too long. And it's happening quite frequently. And if our threshold's 100, and we're seeing that this is all over the place, this is jumping up, there's something critical going on here that we need to investigate. There's also some queuing. These throttle requests, what happens is when the Sprock and queue latency gets so high to the fact where it's realized the SIP stack realizes that it's not fulfilling requests as fast as it needs to. So what happens is it goes into this throttle mode. And when it goes into the throttle mode, then it says, hey, I can only take X number of requests from you, until it catches up, and then it drops the throttling mechanisms. All right, so just wanted to go into a little bit more detail on some of these other system counters that are beyond threshold. Page life expectancy. This is super important. So on our front-end servers, something to take note of, we have multiple instances of SQL Server Express. Nothing wrong with that. But there's also a limitation for the buffer cache. The buffer cache is how much it can reference key pages to in memory. And what happens is, as the busier and busier and busier things get, if there's underlying contention, the less it's going to be able to go through and effectively utilize the cache that is available to us. So you can see from looking at this across the board that this is a flipped counter, by the way. The min is important, not the max. From looking at the burst rate, that it's all accurately reflected. But what this means is that on average, things are staying in SQL, in cache, for a maximum of 125 seconds. So things aren't essentially staying in cache long enough. So as we go through and break these out, you can actually see on some of these front-end servers, it gets down to 2 seconds. On that server, essentially what happens is, if your cache can't keep up or you run out, you're going to go through and essentially treat the disk like memory, because it can't keep it in memory. So it's going to have to go through and fetch out to disk every single time. So what that's going to do is all across the database instances, across anything that needs to go through and actually access the disk, it essentially while there's one piece that has a bottleneck, it creates a system-wide bottleneck for everything. So what we can see here is SQL is definitely not healthy, but we don't know why. From looking at the disk writes per second, there's a couple things that we can notice. And by the way, when we look at disk, it's important that we look at the disk where the data and log drives are stored. The C drive we're not particularly super interested in. So we can go through and see that when we look at these maxes for some of the hours, when it's this is measured in seconds. So to go through and do a read or write from the disk, or in this case a write, and it's taking over a second, that's terrible. For SQL, we expect things to really be chugging along and be 15 milliseconds. When we get beyond that, things start kind of going sideways a little bit. So the other thing that's really interesting is, as we go through and look at these front-end servers, something is clearly wrong. Something super fundamental. It's our CPU. Look at it. There's times here where the max is 100, and it happened 27 times over the course of that hour. That's going to have a system-wide effect. So from looking at this data, you can clearly go through and see here that there's a ton of things going on, and that fundamentally the issue is there's a capacity problem with these servers. We don't have enough CPU, and the disks are not adequately handling the load. From looking at this table, this is the last thing that we've got inside of the spreadsheet. If the pivots that we've provided in box aren't doing, or if they're not providing you with the information that you're looking for, you can go through, and this is just the raw data that we have. So you can go through here and create your own pivots based off of what we have here. Additionally, the last thing I'll show you on the spreadsheet is we do have some hidden worksheets. If you wanted to go through, for instance, if you know in your environment, there's always going to be on a managed network, and you're going to drop X number of packets, and you don't want it flagged on the report anymore, you can come into this core facts worksheet, and you can find the healthy range and change it to whatever makes sense for your environment. And then when you rerun your data, it'll use those thresholds. So, last thing before we jump back into the slides. This is just a quick peek at our guide. And what's interesting here is, from looking at this, is we knew that we had CPU problems. So we can come in here, it'll tell us where we need to measure it, what the trending health direction is, and what we need to do. Why this is super helpful is because while we went through and we saw that the CPUs were at 100%, now since Windows 2008, 100% CPU does not mean that it's necessarily capped out hardware-wise at 100%. It could mean that you have a power profile turned on, or a power plan, where it's actually throttling down the cores to reduce its carbon footprint. So there's some other perf counters that we can go through and check, make sure that we've looked at this max percent of frequency to make sure that we are in fact pushing the CPUs to their max before we go through and really remediate much further. So that's just one example. The guide's all there for every counter that we have. And so whatever you need to go through and look at or get guidance for how to make it green, it's all there. So I think you can see what problems this is really set out to solve. It's helpful with ambiguous problems. If someone says, hey, link felt slow today. I mean, as an administrator, what do you do about that? That's pretty ambiguous. You know, what's the next step? So you can use the KHIs to go through and dig deeper into that. Additionally, if someone says, hey, I joined a conference call this morning, and when I joined, all I heard was ding, ding, ding. You know, you heard 5 or 6 of those. Why did it take so long? Maybe there's a top of the hour problem, and maybe the KHIs will go through and help you find that. And I'm sure everyone here for your deployments has gone through and utilized the link stress and performance tool, or the forthcoming version that we'll have for Skype for Business, and make sure that all of your environments have the proper capacity. Using the KHIs is one instance where you can do that, to go through and really make sure essentially it's like checking your math, just to make sure that the assertions that you made in the planning cycle actually are right as you go through and do your deployment. And then catching what active monitoring may not. So this is really referring to, this process is considered passive monitoring. SCOM is active monitoring. And what's interesting about that is for SCOM to go through and catch something, it goes through and pulls the performance counters every 15 minutes. When it goes through and does this, if it sees that there's a problem, it then waits. And then it says, okay, well, I'm going to compare the first sample where it was bad to the second one. Let that happen a couple times, then I'm going to send the admin an alert. So for these top of the hour type of problems, you really need something that's higher resolution to go through and find some of these problems. So don't let this become your deployment. I was on the expo floor the other day, and I saw this Jenga-looking tower. And the KHIs really help you make sure that you have a solid foundation and that you don't have a Jenga tower and that you've got something that's rock solid. So for new deployments, you should run this weekly for a little bit just to make sure that your environment's right-sized. Once you've done that, you can cut back to only when major things happen in your environment. And we would also recommend that you run this with the interval duration of 15 seconds for collecting samples to in at least a business day. Hopefully a week, but at least a business day or a week we find is the best timing to go through and review the data. So we've already touched on the remediation concept. Obviously, the system stuff first, the queuing things in the first layer, and then working your way backwards. All right, Andrew touched on this. Before remediating, we find that it's real easy to get in the weeds and dig real deep, look at CLS, go through all these logs, and you may not need to do that. It's usually the simpler answer that's the solution. And it's making sure that Windows is up to date, you have the latest Skype for Business and Link Server 2013 patches, SQL's patched, all the hardware stuff is handled. So before you spend a ton of time really digging deep, make sure that this stuff is handled. And the KHIs themselves, they're not a supplement for other processes or tools. They're meant to be used in tandem with other processes. You need to have synthetic transactions. You need to have a System Center Operation Manager, a monitoring server, call quality methodology. All these things come together to ensure that there's a great customer experience. All right. When I put this together, I wanted to really make it stick for all the architecture dependencies and what the building blocks are for this product. And if you were to go through and knock out SQL or disk or CPU, it's an additive effect all the way up the stack. So, and again, we've got this sorted by ring 0, 1, and 2. Just keep in mind, as you're doing your remediation, always focus on ring 0 first. And then, coming soon, you may have seen this yesterday. We have the real-time dashboard. Doesn't have a name yet, but what's interesting about it is, if you look at the bottom, this is a representation of, Microsoft has a ton of sites, a ton of different pools. This is showing 4 pools in 3 different sites, and each one of those green little boxes represents one perf counter on one front-end server. So it gives you the ability to see in real time how the servers are performing. Great for operations. If you have a wall mount display and you want to see the KHIs, you can use this for that. Additionally, you can also use it for if you wanted to understand how many connections you have, how many people are using app sharing, any workload, you can go through and create your own dashboard and see it in real time with this. So this is coming in Q3 of this calendar year. In summary, we've got a whole bunch of stuff out for the KHIs now, aka.ms/KHI. In a little bit, we'll be releasing a real-time dashboard to help monitor the KHIs. And most importantly, we want to hear from you. If you have any feedback, if there's something missing, if there's something we can do, we really are passionate in making sure that we're providing you with the right guidance. If something's missing, please don't hesitate to give us feedback. So, thank you.
Hello? Hello? Hello. My name is Jens Trier Rasmussen. I work in the same group as the other 2 gentlemen, and I will talk about call quality and what's new in CQM and a bit about what's new in Skype for Business. I will start with a demo as well. So the call quality methodology and the call quality scorecard, it's like a 2-step process. First, we run scripts to collect the data into CSV file, much as the same as the KSI tool. And then we have an Excel workbook that loads the data and draw charts. So this, let me see, can you see it or should I do this? So here you see running the script, the collection script. So what you have to do is specify a start time and an end time, and then you have to specify which CDR and QoE database that we will be targeting, the version, and where you will store the data. And if you put -verbose, it will show you the query it runs and the number of rows it returns, so the number of data it returns. Right here, you can see one of the new things that we have done in the upcoming version 1.5. We are not just looking at QoE data now, we are also looking at CDR data for the reliability. So let's assume that this is done, and I will now try to load the data. Do I need to use Zoom it, or is it okay as it is? Okay. So this is the beta version of the new workbook, the sequence scorecard. One of the larger changes is I have changed the name now. Instead of it says link server, it's now Skype for Business server in the first row. No. So the way it works is you need to read the CSV files. The CSV files are formatted based on the server that you collect them on. So the comma might be the dot or the real comma, depending on your local settings. And there is also problems with the date. Is it month first, year first, and all these kind of things. So I have dropped boxes to control that. And it will default to the settings of your PC. And then we have the ability to remove off work days, because they will create spikes. Those features are not new in 1.5. We had them in previous version as well. Let's start by importing the data from the previous run. So you just pointed at the folder that you received from that share you pointed the script to. That's the collection script will create a folder named CQN_data and the date that you ran it, and then it has all the files in that folder. So you just pointed at it, and then I'm reading the CSV files and creating charts, and I'm hiding any UI activity while I do it. But you can see now that I have created a number of tabs. And you can see here in the list there are quite a few tabs. Let me start by showing you, this one. One of the changes that we have made in 1.5, as Andrew also mentioned, is that we have changed our default poor stream condition. So we are now operating with 1 for server-to-server streams, which is the 1% packet loss, and then we are operating with the classified poor call for the other streams. And this tab in the workbook shows you which condition was used when you ran the collection. On the PowerShell script, you can specify which condition you want. You can even specify your own custom condition. But this shows you that we have used the classified poor call. You have to know that this is the case, but that is the definition of the classified poor call. And then for the server-to-server poor streams, we are using the just 1%. So that was one of the new things. Let me go back to start. This generate stream distribution will show you, based on these different media paths Andrew mentioned on the chart, how many good streams you have, which is in green, and how many poor streams you have based on the condition specified. And those are in red. All this data is coming out of my lab, so there are not that many good or poor streams. We have not made very many changes here. We have just added the column E, the poor stream percentage, here. So there's not a lot new there. The other thing you can do is you can generate these trending charts, and that shows over time how the poor stream ratio is and how many streams that you have in total. In my environment, I don't have a lot of traffic, as you can see, but let me show you one of the new things that we have added. So we have the wired chart there. That shows you wired clients, internal talking to AVMCU or mediation server. In Skype for Business, we have this new feature called Rate My Call, where you, as the admin, can specify that the user will get a survey after each X calls that he or she performs. And when they fill in that survey, the data will be sent to the QoE metrics database. What we are showing here is how the average rating is over time for the same period as the wired. So it's for each section where we have rate my calls, we will show these charts. So you can see, okay, there is a spike in the poor streams around New Year, but no users are complaining. In fact, it's declining at that point. So maybe we don't need to do anything. So the idea is, in the past, there were no correlation about what the end users felt and what the metrics were telling us. Now we have this correlation between rate my call data and the metrics from the call. The other big thing that we have added is reliability data. So this is data coming out of the CDR database of the call and diagnostic information from the call. And we are creating two types of charts: reliability for peer-to-peer calls and reliability for conference calls. And we are showing it in charts like this. The reason why you see those spikes, it's a bit problem to wear glasses, is because we have We have fixed the scale of the axis to the right at 5%, so these spikes are over that 5%. And you will see the number of P2P sessions is in blue, and then the number of failed P2P sessions, percentage, and mid-call P2P sessions. And we do that for both PSTN, P2P conference session. And in the documentation, we provide you with guidance how to go about remediating these problems. And we also have additional diagnostic queries you can run against CDR to better understand where the problems are. Lastly, we have the top issues where we show interesting information about various elements like devices, endpoints, and so on. As again, my lab is not very interesting, but you would, in other deployment, you will see a lot more data here. And you can use that data to get an idea of where you need to remediate. Lastly, we have the scorecard itself. So when you click Update Scorecard, we will create this view of the different media paths and color code it depending on the targets and the actual data. So the targets here, for instance, you can see 1%, as Andrew mentioned, that's the new target. If you change it and update the scorecard, it will potentially change the coloring. And we give you guidance over here of what to do for remediation. Okay. I believe that was what I wanted to describe. I'm planning to release this after this conference. So before end of May, I will release it. Let's go back to the deck. Which one is the deck, Brandon? Do you know? 5. One of the themes for the new version of the scorecard was that we wanted to align with the call quality dashboard, that new reporting tool that Andrew mentioned. So that's one of the reasons why we have changed our definition of a poor call, because we want to make sure that the customer can use both tools and see the same kind of results. There will be a talk later today that will go into more details about call quality dashboard. The other thing was that we wanted to show these reliability information and also surface the rate my call data. The reliability information is coming out of work that we have done on our internal deployment, one of our colleagues, Sasha, has been doing. Let me quickly go through these slides that I have already covered. One important thing to mention is, as I said, you can specify the poor stream condition when you are collecting the data. You can't change the poor stream condition when you are in the Excel sheet and update the numbers based of changing that. Then you need to rerun the scripts with another definition and load it into Excel. So I wanted to touch upon what has changed in Skype for Business with regarding to media quality, and talk a bit about how to upgrade and keep your data from your 2013 deployments. The new Skype for Business server needs its own version of the monitoring database. I don't know if you know it, but inside the topology, we are using service versions for the different components, and Skype for Business is version 7, and it needs a monitoring database that is version 7. Link 2013 is version 6. So you can't point your Skype for Business servers to a Link 2013 monitoring database. But what do you want? The other the reverse is true. If you are running with at least CU5, which is like a somewhat older patch level on the 2013 server, you can point that to a Skype for Business server when you have the Skype for Business topology builder. And you need to do it in topology builder. The old topology builder doesn't know about the Skype for Business. So how to upgrade and keep your existing data? There is really only one way of doing it. In the topology, your monitoring database is associated with one or more pools. And when you start upgrading one of those pools, Topology Builder will ask you, do you want to upgrade the monitoring database as well? And at that point, you should say yes. The only thing you need to check is that all the link servers using that database is on CU5 or older, younger. Newer, yeah. You get it. Because when you say yes to upgrading it, the service version of the database will be changed, and then the pre-CU5 2013 servers will no longer be able to send data to it. After you have upgraded in the topology, you need to update the database schema, because we are adding some new fields and stuff in the database, some new tables. So you need to install CS database type monitoring, update, and a number of other switches. Topology Builder will do that for you if you're using that. When you have done that, as I said, the existing 2013 pools will still be able to send data to it, and you will have one view of your deployment. If you are not doing this, but you are creating a new monitoring database for Skype for Business, then you basically have two separate environments. We don't provide any tools that will give you an end-to-end view of calls, for instance, where one person is homed on 2013 and one person is homed on Skype for Business. So upgrading is the only way to keep that one view. There might be reasons why you want to get rid of the old data, but the default should be to upgrade. I was talking about the rate my call. Here is the UI that the end user will see. We will show both audio and video. If audio or video is used in the stream, the UI will be visible for 20 seconds, and if you don't touch that window, it will just disappear. If you have touched it, it will stay until you get rid of it. It has a 1 to 5 star rating, and it has some pre-configured issues that the users can check. There is no customization of that list. The only thing you can customize is if you want the free text format box, and how many times the survey will be shown. I think I have it on the next slide. Yeah. The user needs to be hosted on Skype for Business server because it's a new policy element in CS client policy. You can specify, as I said, how often it's displayed. The percentage is like for each. So if you have 100%, it will be shown for each call. If you have 10, it will be for each 10 call for each individual users. And we are not showing it in some cases. For instance, if you are in Do Not Disturb, we won't give the survey to you, even if it's your X call, and if it was an emergency call, and so on. We are keeping the data in 3 new tables in the QRE metrics database, and I've listed the tables. And we will show the data in both CQM, the new version as I showed, and also in CQD. And if you want to look at the data yourself, on TechNet, I created some custom SQL queries that you can get to. And you can see here I've ran those queries to show how it looks for the demo I just showed on the previous slide. Some more new tables that we have in Skype for Business, and we have also updated a lot of tables. We have added a host of Wi-Fi metrics, and that's based on the work that we have been doing internally to improve our quality and Wi-Fi. So you get a lot more data now on your Wi-Fi statistics. You will have to use Skype for Business 2015 client to send those new metrics. Yeah, call quality dashboard. That's this new tool that we made available on Monday, and I will not talk a lot more about it on this slide. There is a session at 12:45. Aaron Steele has a session where he will demo it more. What I will do is I will try to do another demo. So you saw the problem in quotes with our CQM scorecard is that it's like this two-stage process. You need to run the PowerShell script to collect the data, you need to get the CSV files, and you need to load them into Excel. Wouldn't it be a lot cooler if you just had the scorecard by itself and just clicked F5 and then it was updated with new data? So that's what I have done. Let me see if I dare press the update. So let's see. So I've created this web page based on a CQD instance that I have in my lab. So when I click F5, it goes to that cube using the API that CQD provides, gets all the data back, and color codes it based on the targets that I have defined. And the data is trickling into the cube. The cube is updating, like each minute it's getting new data. So this is like almost real-time updates of the scorecard. It's not real-time because there's quite a long distance from here to Denmark and then back. But you get the idea. And you can see it's not just, I don't know if you noticed, but there are a lot of calls, right? I don't have all the elements of the scorecard because the cube is not storing some of the device information. So I just surfaced what I could get from the cube. Let me show you how it looks in the actual code. You use JavaScript for this API. So I have an HTML page, and then I created the queries. So this is a query. So it's using dimensions, filters, and measures. And the way to understand how to write the queries is that you use the call quality dashboard reports, the UI, and get the query as you want. Then there is a way to see the actual query as I have it. You can, for instance, use F12. We will also provide a way where you can go to that report and get this output exactly, and then you can copy and paste it into your HTML page. And then I just issue the query here. And this is basically how I'm color coding, right? There needs to be the business logic for how to color code the data. But I just wanted to show that this is like, this is the future, right? Get rid of all this PowerShell stuff, get rid of Excel, and just show it in a dashboard. Okay? Yeah. We have 1.5 minutes left for questions.
So,
yeah. Okay.
So we're done. We got one more slide, I think. Yeah. So here's what we want you to do. I mean, we've covered a whole bunch of stuff. But basically, we want you to use the KHIs. If you're seeing issues, we want you to use the CQM scorecard. We'll get this implemented on top of CQD, as Jens said. Make sure you're looking at this environment. You go through this iterative process, right? You look at it, you figure out what the right targets are, you reach those targets, and you keep looking at it. So this has been a passion of ours for a couple years. Hope this guys is helpful for you guys. We'll stick around for questions, and thank you.